Okay, welcome back, and we're up to DC motor video number 3. So let's now have a look in more detail what's going on with this force on the conductors in the motor. Just to remind you, in the previous video we worked out with our conductor arranged in this way that the force on the left hand side of the conductor was going to be down, the force over here is acting up, and this is going to cause, or we can see it's going to try to cause the coil to start to rotate in the anti-clockwise direction. So now let's look at what's going to happen once it starts to move a little bit. So, whoops, wrong one. So let's now perhaps zoom in a bit. So we'll draw our north side of that magnet there and our south side of our magnet there, and that means that our magnetic field is still travelling in this direction from north to south. I'll try to draw it fairly evenly. There we go. So there's our magnetic field. So our conductor was wanting to move in the anti-clockwise direction. So conductor side B would have moved up a little bit, and the one over here, the side A of the conductor, would have rotated this way a bit. So now the position of the two ends of the conductor should be something like this. So side A of the conductor will be there, for example, and side B of the conductor will be something maybe like that. Now we're still assuming that these two conductors are connected to the same battery and the current is still flowing through in the same direction. So we'll just to remind ourselves that the left hand of the side of the conductor was, the A side was connected to the positive end of the battery. I keep doing that incorrectly. Okay, so that's still connected to the positive end of the battery. So that's still positive. And this side here is still connected to the negative end of the battery, which means that current will be travelling through conductor A, going around and coming back out through side B. So this is side A and this is side B, and current's going into the conductor there and coming out of the conductor there. So if we apply our right hand slap rule again, you may realise that the forces are still acting in the same direction. So over here, the force is still acting down, and the force on this side of the conductor is still acting upward. And so our conductor is still wanting to rotate in the anti-clockwise direction. So it's still being forced to move in that sort of rotational motion, assuming it's sort of spinning around the axis there. So it's still wanting to move around in that direction. So if we now look at what happens when it reaches the vertical position, so we'll draw these magnets again. So North Pole, South Pole, and our magnetic field lines run from left to right like that. So now the conductor is moved in such a way that side B will now be positioned here. And side A that was originally here was now rotated around to the lower position. Now if you remember, side A had the current going into the conductor in that direction, and side B it was coming out. And so using our right hand slap rule again, we can still verify. Remember that our fingers will point, if we're looking at conductor side A, the fingers point to the right, thumb goes into the page, therefore your palm points down, so the force is acting that way. Looking at conductor B, our thumb will point out towards us, our fingers will point to the right, and so the force will be pointing upwards. Now, remember this is a rotating or a conductor that's connected, so the sort of conductor goes around and it's trying to rotate around this point here in the middle. But guess what? Now, all the forces are trying to do is to pull the loop of wire apart. There's no longer any force trying to turn the conductor. It just wants to, this side of the conductor is being pulled this direction, this side of the conductor is being pulled in this direction. There's no longer any force wanting to turn the loop of wire. So in other words, our motor, after turning just quarter of a turn, is going to get stuck. And it will not move anymore. So how do we fix this position? How do we deal with this problem? Well, what we ideally want to do is somehow get these forces to change their direction, so they want to keep keep the loop of wire turning in the same direction. So if this had a little bit of momentum after it reached vertical and just kept on going, and we were somehow able to flip that force so it was pointing down, and this one so it's pointing up, then that would hopefully keep the motor turning in the same direction. So the trick to getting a DC electric motor to continually turn around and around and around, rather than getting stuck before the first rotation, is we need to keep flipping the force every half a turn so that it keeps wanting to move the conductor the loop of wire in the same direction. How do we achieve that? That change or reversal of the force is achieved using a commutator. And that's what we're going to be talking about in our next video.